We're going to talk about how we are able to leverage Istio's capabilities to create API tests at a much more rapid pace and efficiently so that we can all improve our developer productivity, the productivity of developers who are building applications on Istio. So we all know that the number of applications being driven by APIs and microservices in general are exploding significantly, right? And this migration towards microservices and distributed services in general has started placing an additional burden on engineering teams in order to create a variety of API tests. It could be things like end-to-end API tests at the gateway layer, could be component tests for specific components in your application, and service tests for each individual service. So if a developer is changing one service, let's say the catalog service in here, he or she needs to test that change thoroughly without having to bring up all the producer services that they need, right? So all of these different kinds of tests, whether service tests and component tests and end-to-end tests, is placing a significant amount of burden on engineering teams. And as the number of APIs and API interactions grow, this burden is only increasing, right? Let's just get some terminology right, because different people have different understanding of what a service test is and what a component test is, especially in the context of these distributed and microservices architectures. So what we mean by a service test is a common understanding as well. We're not changing it, but let's just be clear here. Have a service. I want to issue a service test request. An API request could be gRPC, could be REST API against my service, and my service depends on these producer services. But I want to run this test either locally on my laptop or in a CI pipeline without having to have these producer services live. So I need to mock that behavior. So that's what we mean by a service test, where only the service that is under test needs to be live and everything else is simulated and mocked, right? So you can test a service in isolation. Now, similarly, a component test is no longer one service, but a group of related services that all of them need to be live, while the rest of the other services that this component depends on will be mocked, right? And typically, services are developed first, and then components evolve, and then the entire application evolves. But once the application is in live, different components, different services can change independently and move forward, evolve as well. And what we are observing is the current approaches to create the service tests, the component tests, and end-to-end tests do not scale, as I already highlighted earlier in the first slide, with the number of APIs and API interactions, right? So the typical approach is, first of all these end-to-end component service tests, API tests are all created manually by engineers. Then they need to create the test scenarios, the test harnesses, the test data, the mock data, everything by hand, and they have to create this tests, and they're all created independently as well. A developer may create a service test, someone else may create a component test, maybe a QA team will create the end-to-end API test, and these are all independently created. They don't talk to each other closely, that they can reuse the data and so on. So, and that places an additional burden when it comes to maintenance, because if an API changes, then I have to recreate or update my service test independently, update my component test independently, update the end-to-end API test independently as well. So this is all an additional headache and burden to the teams. So what some of the teams end up is, okay, let's just focus on unit tests and end-to-end tests, and ignore the component and service tests. And that's really bad from a development and release quality perspective, because you develop a particular service, you update an API, either request or response, and you wait for all the other services in your component to evolve as well, and application to evolve as well, and finally test the integration and the functionality as well. And that's when you identify problems, and then you have to go back. So that violates the shift left paradigm, and you discover your bugs late, and all of these bad issues happen. So that's not at all good from a development team perspective. What we need, right? We want to first of all start testing earlier, shift left as early as possible, right? And we want to achieve a balanced test pyramid in that context. We want to place more emphasis on unit tests, then service tests, and component tests, and finally end-to-end tests, which are much more expensive to create, maintain, and run as well, right? And we want to do all of this with as little engineering effort as we can, right? And that is the ideal goal we need to be at now. And that's what the rest of the talk is going to focus on. How can we achieve that state? Be able to shift your testing earlier, achieve a balanced test pyramid, and be able to create and maintain these different types of tests with as little effort as needed, right? So Istio, what we observed as we were exploring this problem was Istio enables this pretty nicely, right? There are a bunch of listener capabilities that we can leverage to actually achieve that. So let's consider an application which has all of these services, and we can deploy listeners, which is sort of Envoy filters. We'll talk about that in detail later at each of these service endpoints, right? And as the traffic comes from a manual QA in your staging environment, or could be an API studio where you can curl requests, or it could be a third-party application that's actually calling these APIs, we're actually listening to this traffic, API requests and responses. And we gather this, it captures this requests and responses, and we add sprinkle a bunch of other things to actually convert this test, the API data that we captured into test suites, right? And when you have a new build that you want to test, maybe entire application, maybe only a component of this application like this, or a separate component, or even an individual service, you can leverage this data and the test suites that we can create from this, learn from this data, and run any of these service tests, component tests, application tests, entire end-to-end API tests, right? With the same data and the same test suite. And the mocks are auto-created. We'll show you how that mocks can be auto-created from all the data that we gather, right? So that in a nutshell is our approach. And this enables rapid API test creation, and not just end-to-end API tests. It can be done for end-to-end API testing, component testing, and individual service testing. And does achieve the goal that we want. So how does the process look like? So you have an Istio application running in a test cluster or a staging cluster. The first step is to deploy Lua filters. We prepare the filters automatically from the service graph. And just one kubectl apply to the filters will actually put all of the services in listener mode. That is, we are able to capture any of the API interactions going through that each of the services, right? And then we drive set of traffic from UI, from a third-party application, from your API studio, any studio that allows API curling APIs. We capture what we call the traces. It's not just one request to the endpoint, but it's the entire trace through the application, right? That's what we capture. And from there, we can create tests and mocks for all of these API endpoints. Then you can configure your system. So from the same test data as I illustrated earlier, you can configure various components. So here is one component, here is a different component, here is the entire application, here is an individual service. All these various configurations can be driven from the same set of tests and mocks. And we'll show you how to mock these various services there. So let's get into the first step. How do we capture the API interaction? Let's consider these three services: service A calling service B, service B calling service C, and we have this filters, Lua filters. All we need to do is kubectl apply minus f that filter file, and now these filters are deployed on the Envoy proxies, and your services are listening to the traffic, right? So as and when there's an API request going through the service A and service A calling service B, now we are capturing at the endpoint of the service A, the endpoint of service B, and at the entry point of service C. And all of this data is captured independently into the mesh dynamics services, right? Once you're able to do that, we now can leverage the tracing, right? So there is a trace ID that is introduced at this endpoint. The same trace ID is propagated through your services. Could be using Datadog, could be using Jaeger or Zipkin, pick your favorite tracing provider. And the trace IDs are propagated through the services. So we know the request A is this original request is generating a request from A to B with the trace R and span S1. And the service B is calling service C with the trace R and the parent span S1 and the new span S2 and so on. So we can reconstruct this trace. Request calls request AB generates a request from B to C and so on, along with the responses as well. So this whole trace is what is captured and reconstructed by Mesh Dynamics automatically. So here again, note that we are leveraging the Istio capabilities to deploy these Lua filters uh, on demand with very little effort, and they're able to capture this data. Right? Whenever you're done with the capture, you can just apply or remove the filters and stop the capture whenever you need to. So what do we have at this point? We have the full trace of every request that went through this service application, the entire application, and it's a full trace. So a request here generates a request to this, a request to that, and so on. All of these are tied to by the same trace IDs, and we have the spans as well. Right? And from this data, now we are able to capture very precise mocks, almost at the request level. So you generate the same request here, and this request is calling a particular service. Now we can add the trace. We can use both the request payload and the trace ID to actually precisely mock that particular request as though this service is live, right? So you don't have to have the services in live, but it's actually mocked. And these mocks are auto-created from the capture data. So that's a value that we can derive from this ability, combining both the observability / tracing along with an intelligent mock service. So once we have that, now we're able to create service tests. Oh yeah, we have all the data. Let me create a service for the catalog service. So I have all the requests that went into the catalog service. I know what egress requests are going to the search and recommender for that in each of these individual requests, and I can automatically create the mocks, right? So we have a service test for catalog. Pick any service, you have a service test for those. Now let's say we want this component test. This component talks to a few other services, and we need to mock those services. So we have all of those. It doesn't have to be so the homepage, catalog, personal history, or live, but some other services that these services may talk to are being mocked, and those mocks are auto-created again, driven by the trace, right? So exactly, the mesh dynamics are auto-creating these mock services, and both the trace ID and the request payload are used by the mock service, and that enables us to precisely mock the state of any service to that individual trace level. So what that means is I can take a trace, perhaps even duplicate it, create a new trace, and change my response. That basically means when a service is being mocked, an API request comes in, I can differentiate between two different responses that need to be given. So, and that level of preciseness and robustness of the mocks are what help you create tests at scale without having to worry about stepping on each other's toes around mocking. So, and as far as mocking is concerned, again, Istio has a nice construct of this virtual service, which we can use to route instead of to a live service. You say, I want to mock this particular service. You just change your configuration and say, oh, this prefix, the API / reviews needs to be rewritten to this mock service. And boom, you have your mocking ready to go. So your service on the test is issuing a request, typically to a live service, but with this mock virtual service configuration, it's now going to our Mesh Dynamics mock services. So it's as simple as that. So again, we are leveraging the Istio to create this on-demand mocking configuration. Whether you want to mock one service or all services, it's up to you. And you can configure any number of configurations here with the same test data, right? So that's about creating mocks and configuring the Istio application with various configurations. You pick and choose which service is live, which service is mocked, and you can have multiple configurations, right? So let's jump into the test creation itself, right? There are a couple of other things. It's not just taking the API traffic and just replaying. You need to actually modify it so that you are able to create test suites out of it. And these are the elements here, the assertion rules and context rules, which I'll talk briefly, that need to be, so you need to take the API requests and responses that we captured. You need to enhance them with these, what we call assertion rules and context rules, which I will talk about briefly in the next few minutes. And that's what enables you to create test suites, right? Now you can take those test suites, you can run them based on your test configuration, whether you have one service or a component or an entire application live. and generate your different types of test service component and end-to-end tests. So let me talk about the context rules first. So when we are navigating, let's go back here. So I have a UI. I'm navigating my user flow. I'm sort of searching for a product, or I'm creating a product, and then I'm getting the product details of the user flow here. Maybe there are other things like buying a product, searching for various products of one type, picking one product, looking at the details, buying that product, and coming back and doing a shopping activity that way, right? So there's various set of user flows that the user may be navigating in the UI, and those are generating sequences of API requests, right? And in that one particular flow, let's take an example sequence where there's a create product API followed by a get details of the product. And the create product always generates a dynamic product ID. And in this particular case, when we recorded the traffic, it's HDSN189 something, so on, right? And the same product ID value is being used in this UPC parameter here to get the details of the product and perhaps the stores that contain the product. So here's that sequence. Now, when we play the test, because this is dynamically generated, the product ID could be different. It could be HDSN 1, 2, 3, 4, blah. Right? Now we need to take that HDSN 1, 2, 3, 4, blah, and insert into the UPC query parameter so that the test actually is meaningful. If you take the old value, this one may or may not produce a meaningful response. You need to take the new product ID and inject here. So this kind of contextual dependencies need to be recognized automatically, because you need to generate this test as automatically as you can. And the contextual dependencies are what we enable and say, first look at the data that we captured. We learn from the data. So there is a contextual dependency here. And so we have a way of removing false positives and avoiding false negatives. And we have these context rules. Engineers can review them if they want. They can customize them if they need to, and take this context rules, and automatically, when they play the data again with this context rules, they'll get the right behavior that they need from a testing perspective. Right? That's number one. That's a assertion. That's a context rule. The second set is assertion rules. So when we capture the response, we have a response saying order ID and order value. Order ID is something, and order value is 58.75. And we know that, yeah, this order ID is always dynamic. When you play the test, you'll get a different order ID. Now, when you're comparing, you need to make sure that you compare only the key for order ID, not the value. For order value, however, you want to compare both the key, the value 58.75, and the order value here as well when you replay the test in a test setting. So that kind of assertions are again automatically learned by the mesh dynamics system based on the data that we have, and we expose them as candidates. Again, developers can bless them, review them, bless them, modify them if they need to, either through the UI or from the backend, either way, whichever way they feel comfortable, and get the behavior that they need. So once we have this assertion rules and the context rules, the data that we captured from the Istio Envoy listeners, the Lua filters which are deployed on this Envoy sidecar proxies, we're able to convert this data into real test suites that could be meaningfully used in a CI pipeline or in a local developer laptop, right? And again, just to illustrate that, or sort of stress that again, so all of these requests and responses that we captured from either in this particular case, the staging environment with the listeners. This could also be envisioned in a developer laptop as well. So we capture that API traffic into this API catalog. And from this catalog, which is the repository of API requests and responses, we're able to create various types of tests, whether it be component and end-to-end tests, could be service tests that are running in a CI pipeline, or could be just local service tests. When a developer changes a service, she can run these local service tests locally without having to worry about all the producers' services being live. So all of these variety of tests and use cases are satisfied just by building on Istio capabilities to capture the traffic easily, to mock services easily, and enable your developers to function at a much more rapid clip. So, in a nutshell, just to summarize the whole presentation, which Rahul will actually demo that for us, Mesh Dynamics is able to leverage some of the critical Istio capabilities to scale API functional and integration testing, enabling us to the development teams to create service tests, component tests, and end-to-end tests with very little engineering effort, and thus improve the productivity of each of your developers that are actually building and deploying applications in Istio. So that ends my part of the presentation. Let's jump into the demo, which Rahul will lead. Feel free to download Mesh Dynamics from our website, meshdynamics.io, and start using it. It's a premium product. Hope we'll hear from some of you and get your feedback.
Okay, so I'm going to do the demo, and just to give a quick background of the things that we'll do. So this, what you see here is our tool. And what I have here is a simple demo application that I'll use to actually create a test case. These are the services in the demo application. So we have a few services. It's obviously it's running on Istio. And all of these, the services talk to each other. You can kind of see the flow. Movie info is the gateway service. So when we make requests from the UI, it comes to movie info. It makes various requests to these services. There could be additional communication across these services. Now, the traditional way of creating tests, of course, will be to create tests by hand. Here, we have the ability, because of Istio, as Venky mentioned, we have the ability to capture those complete traces. So you can just go to the UI, go through expected user flows, and we can capture those complete traces for the API requests that are generated and create tests out of this. So here, for the sake of expediency, that's what we are going to do. I'm going to put our application in record mode and capture and go to the UI, do some stuff there, and capture the API requests. Okay, so I'm going to put this in capture mode. Let's call it Istio. Start. Okay, so now this is in record mode, and it's capturing all of the traces, the API interaction traces. And this is our demo app. Think of it as an online library system. So you can click on an item to get the details. When you render the details, pull out the information about the reviews, where it's available for rental, etc. We capture all the APIs behind them, complete with the full traces. And then you can go ahead and go through a process to rent this movie. So you can say rent, and once again, we capture all of the APIs behind that, right? So let's kind of go through a couple of use cases. Let's say the first use case is just listing an item. So here I clicked and listed an item. And let's say the second use case I want to create API test from is somebody lists an item and then go through the rental process. So go through that, do something here, so rent. Okay, so that's enough. That's all we need from here. We are done with that. So now I'm going to stop the recording. So what we did here was, we could have also created all of these API requests manually from the tool. Obviously, it's 100 times more efficient to just go to the UI, go through the user flows. Because of Istio, we can just capture the entire traces. It just reduces the amount of effort that's involved very significantly. So let's wait for the capture to finish. Okay, so now the capture is finished. Let me quickly show you the kind of information we captured there. So here, let me select what we did. So here is the file the test file that we created. So if you look here, you will see that we have the information about all the different services from which captured API requests. Here are all the APIs, and here are the APIs which you can group by service. So I can say movie info, what are the list movies. So here are all the instances of this API that we captured. And if you dig into into the details of this, you can just click them here, and you see all of the details over here. So if you notice here, you will see here's the request to that service. And then we show you the egress request test. Now, internally, we have the complete trace. If there are multiple levels traversed, we have the complete trace, which I'll show you. But here, this particular part of the tool, we just show you the egress request from a single service. Okay. Now, obviously, you can go there, you can edit all those requests, you can update the tests, add additional requests. Here, for the sake of time, let's say I want to run exactly what I captured. I am not going to make any changes. So let me do that. Now, the beauty of what we can do with this is we captured end-to-end requests. We can now slice and dice that any way we want. Because of Istio, we can say, okay, I want to, for example, I can say, okay, here I want to test just the review service, and our replay driver can just pick out the review service. And if you need to mock something, you decide what you want. Here, I can test the movie info service. I can leave all the services live, or I can mock some of them, or I can mock all of them. So I have a couple of configurations set up here. So let's sorry. So here I have two configurations set up here. In one of them, I'm mocking two of the services. In the other test configuration, I'm mocking all the services. So let's pick this one. So here, if I run a test for movie info, I'm mocking all of the services. And once again, that got all automatically created from the data that we did, that we generated. So let's go ahead and start that test. So I just need to test that file, Istio, that I created, select, and say run. So now this test is running with this particular configuration. Our replay driver is saying, okay, the service you're testing is movie info. You're mocking all of these services. So we are replaying the requests that go to movie info to the movie info service in the test cluster. And when the egress requests come, we have configured here, obviously, for this, once again, we are not going to change it manually here for the sake of time, but here we have configured it using Istio, where all of these services are being mocked and the requests are being forwarded to our mock services. Okay, so this is done. And before jumping into showing you the results, let me also now go to the other configuration, right? So I'm now going to pick this one where only two of the services are mocked. So think of it as a component. The component that I want to test is this component. I want to test this, and sorry, that's the other way. So I want to test this component with these guys, and these other guys, I'm not interested. These are not part of the component that I want to test, so I can leave them live. I will just interact with them. So this is the component that we are testing. And so I will pick that configuration, or they've already picked that configuration. And now say, once again, it's the same test, Istio. I'm just going to say run test. While it's running, let's go and start looking at the results we got from the other tests that we did. Okay, so this is the test, the previous test that we ran at 1208 over here. You can see run with the test file Istio. So it's showing you all of the various services that were part of that test. Movie info was the only live service, and you can see it's showing a red there. Now, if I expand this, here are the three APIs that we captured from our interactions, didn't capture login. So two of the APIs, they tested fine. This API is showing red, so something's wrong here. So now if I look at this, let it just load. So the first thing I want to show you is the trace. So here you can see what we captured here. This is a recorded request. So you can see what we captured was the request came into movie info called reviews called ratings, then movie info called restaurant ratings, etc. in order. Now, if you remember for this one, the configuration was all of these egress services were mocked. And it turns out that all the requests were actually, none of the requests to these services changed. So obviously the responses don't change either. So everything's good. So this red, whatever it is happening only in this list movies API, only at this level. None of the other services are affected. Now, by now, I think the other test probably has finished too. Let me just refresh that one, refresh the screen here. Oops. Okay, so here the 1209, this is the second test we ran. And if you look at the signature here, because it was a little bit different, here obviously there are a lot more reds here, as you can see, compared to the other configuration. And here you can see if you remember, we only mocked two of the services, the other two services were live. So something's changed in rent movie. So now if I look at list movies here and see what the signature of what has changed. So if I once again do the trace, so the recording is fine, but here you can see is obviously the same recording behavior, the same thing. But you can see during the replay, this detail service, which we made live, Now that something has changed in the response of that. And to look at, if you want to dig into what has changed here, you can just click in here. So we are showing you, okay, here's the response. And you can see what has changed is actually the response from the service in that other instance, the one that we used for testing. That's actually sending a much more abbreviated response. A lot of the things that probably should have been there in the response, those are missing. So we are saying, okay, there's a problem. And now, so you can essentially go down that trace and see where things have changed. And if you go back at the top level, now here I suspect that, yeah. So here you can see that change is reflected here. We use that piece of information here. That's the change that you see. But there are also other changes that are there in the service itself. So this makes the whole process of creating the tests, having that visibility down that entire trace where things have changed, makes that process a lot easier by leveraging Istio and the ability to mock all of these things or keep any part of that service live. Now, there are the other capabilities that we have built here. If you're actually using this, now the question is, what do you do at this point, right? So you have a problem here. So ratings may, or rather details, maybe something has changed here. Maybe it's a problem. So what you can do here is, from a real user perspective, you can go and, for example, you can look at go into those APIs over here. You can go ahead and you can file bugs. So you can go ahead and file a bug over here to Jira. We have a Jira integration. You can go ahead and file. And if you file the bug, it'll include all of that information. You can also change the assertion rules as well as update these mocks. Obviously, live services we cannot update, but the mocks you can update directly from here. So in this, so if we go back to our previous item here, so if we look at the list movies, which is the API we were testing. So for example, if excuse me, you have changed something and maybe you have gotten rid of this actor's last name error, you can go here and say, I want to update this data file, the reference, what we call golden, and you can say, okay, I want to just remove those. So similarly, if there are changes that you're making, you can, and all you need to do is change the data, you can do them from here. But if you actually need to edit the APIs, make changes for those, you'll have to go into our tool. You have to go into the tool here. As I showed you, we picked up a couple of requests here. So you can go in here, make whatever changes you need to. If you need to add parameters, etc., you can add them here. If you expect that the result will change, you can make the edits over here. You can add in something over here. For example, I can just add in another item. I can update the expected results, put in whatever, and then I can save this. All this that'll update the test. So you can update the tests using all of this information. And once again, the main benefit goes back to, now that I have created the end-to-end test, I can just reuse it for service testing. I don't have to create a huge amount of engineering effort writing service tests where I test that service in isolation. I can just create it from there. The component test, and I can just create from the same effort. And all this effort is reusable. If I go ahead and make a change to one of the things, that gets propagated across the service test, end-to-end test, it's everything. And you can leverage all of this. All of this, made courtesy of Istio, makes the whole process a lot easier. So that's the demo of the product.